Welcome to our next installment in Facts and Fit Testing. Today I'm with Dr. Stephanie Lynch. My name is Luke Allen, President of OHD. We'll be covering breathing during fit testing today, and really some questions around that, like, is it better to have a person breathing during a fit test or some version of that? So, Dr. Lynch, let's just start there. Is it better to have someone breathing during a fit test?
Well, we get that question all the time, and not really, right? Because when you're sitting there breathing during a fit test, do you think you're breathing at the rate that you would be on your job? Your normal resting rate is not typically comparable to what you might see as you go out and perform the daily functions of your job, right?
Right.
So I would say no. With controlled negative pressure, which we do here, you're going to have a challenge rate, a pressure that's going to put a challenge on that respirator. And it's proven and intended to challenge the mask. So that we're putting that actual pressure on the respirator to make sure it's holding up and providing that adequate protection.
I think to me it would be great to breathe during a fit test if you're breathing at the rate that you are in the real world workplace. And that's the issue, right? The question is, are you breathing at that level? So if you're a first responder, if you're a law enforcement agent, or you're in an industrial setting where it's very rigorous, are you breathing and challenging that mask at that level in a fit test? And normally, when I've seen fit testing done in the real world, in the workplace, very rarely in a clinical setting are people challenging that mask at that level. It's normally a normal breathing, or they're slowly moving their head side to side. And the question is that really challenging the breathing rate?
Or is it really representative?
Is it representative?
And also, it would be asking a lot of a subject to go into a fit test and replicate that breathing rate.
Right.
To go through their test and actually be able to challenge the mask appropriately. And one person's opinion of what's appropriate might not match with someone else.
Sure.
So we based ours on science and research that's challenging the mask appropriately.
Well, that's a good segue into the next point. So if C&P, you're not breathing during the fit test when you're challenging that part of the mask, how does controlled negative pressure set the breathing rates? Or is it just an assumption, or is it based on science and research?
It is most definitely not an assumption, and it's not some arbitrary number that we came up with, right? It was based on research that found that the inspiratory pressure is the primary driving force behind respirator leakage. And OSHA, of course, agreed with that research, and so they set our rates. Our rates are actually in the regulation. They're set by OSHA because OSHA and OHD believe that those rates are representative and that they challenge the mask in an appropriate way.
So we're pulling consistent breathing rates set by OSHA for every employee, every time, every step. So there's no variability with subjectivity. Your breathing rate in a fit test might be different than mine, but OSHA set these rates so that we know we have the same exact challenge each time. I think that's important because when you talk about reproducibility and you talk about accuracy, making sure that the challenge is the same level. The other nice thing is that we can dial up higher breathing rate pressures. So one example is in the NFPA regulations, you have a 100 liter per minute breathing rate that's applied through flow testing, if you're familiar with that. Different methods of testing use breathing rates. So it's not just controlled negative pressure. Flow testing use breathing rates on masks to confirm that they work and seal. Same thing on respirators being qualified for certification uses breathing rates. So this isn't just a C&P weird concept. This is a commonality used across a number of different methods. But I think the other thing is being able to dial up higher challenge pressures. You could not reproduce 93 liters or greater per minute of breathing rate by a human subject.
Not for the duration of a fit test.
Exactly. So controlled negative pressure allows you to dial up those higher breathing rates that you really would see in a real world application where you really don't challenge them that way in other methods of fit testing.
That's absolutely true. And when you think about other methods of testing with aerosols, the subject is breathing, but that rate isn't representative. It's not going to be representative of how they're doing on the job, and it's not even meant, right, to challenge the respirator. They're looking for aerosols coming through, and they're even using then, on the whole other side of this, a probe that's going to be picking up the particles that come into the respirator and comparing them to the number that they see outside of the respirator.
Right.
And that probe is pulling it less than or equal to 1 liter per minute. Whereas even at that normal resting rate, your lungs are pulling at around 30 liters per minute.
Right.
So where do you think that most of those particles are going to go?
Yeah, so that brings in the other part is like you said, that they're not looking for just air leakage or pressure, right? So they're looking for the particulate. So you're hoping that a particle finds a leak source, and then you're hoping that the particle comes into the mask and then gets into the sample tube and then goes down and is coated and counted with alcohol and counted. But there's so many other variables to that. There's lung deposition, you mentioned that. So if you're breathing at 30 liters per minute and the probe's at, whatever, 1 or 2 liters per minute, the particle's got a much higher chance to go into the lungs. How likely is the particle to come out?
Yep.
How many come out? The other dynamic is flow dynamics in the mask. So how many of those particles get exhaled out of the respirator and are never counted? You have to count 100% of the particles that come into the mask to have an accurate fit factor.
Well, and the word hope was that's a really appropriate word here, because you are hoping to identify those particles because you want to know if your respirator is leaking. Mm-hmm. That's how you know that your fit test has been successful and that your instrumentation is doing what it says it's going to do, right? Identifying leakage in your respirator. So hope was the perfect word there.
So going back to C&P, we're not worried about particle migration or the counting of that. We're using air as the challenge agent, and we're pulling a consistent breathing rate that's set by research and standards, reproducible for every fit test, every step, every time, for every person.
Right. We're not just hoping that a particle makes it to a point.
Yeah, very good point. So really, I think that ends with why it's so important to have a demonstration of any technology that you're looking for in fit testing, or really any industrial hygiene level instrument. You need to have an on-site demonstration to understand and see how these different technologies work and why they work the way they do, and how to look at accuracy and fit test time and all the other components, but also today what we talked about, which is breathing during fit testing. Thanks for joining us.